I'll put my email in the chat, and you guys can private email me.
Thank you.
Hi, good morning.
You what?
Good morning.
Okay.
Good morning or good afternoon.
Hi, oh, good afternoon.
Mute yourself, please.
Yes? Bueno, ya voy. We are 53 people. Do we wait a few minutes to more people to appear, maybe?
Yeah, Professor, I would wait until like maybe 1:35-ish to see how, like 1:37 maybe, just to see.
Okay. So, how are you doing with the homework? Most of you. Did you finish the homework?
I'm missing one section on Unit 2, but I was wondering when Unit 3 was due, since we got an extension on Unit 2.
I just opened Unit 3, but I have not finished to upload everything. I think I will finish today.
He's not going to make the due date for Unit 3 homework until he's done posting all of the Unit 3 stuff. After then he'll like evaluate like
the due date for Unit 1 and 2 is Sunday.
Okay, thank you. Understood.
Sorry. Okay, we are 59 people. 59 people. So I would like to do one more problems from the homework. So please, can you tell me which problem would you like to do?
Yeah.
Yes?
Yeah. 1 second.
Yes, yes. Which problem you want?
I have a question.
Yes.
I just don't know, you know how the dot product has two formulas, one with cosine and then one that's like that you derive by doing the FOIL. When do you know when to use which formula?
Well, it's very easy. If I give you two vectors and I give you all the components of the vectors, and this is the only thing that I gave you, the components of the vectors. Let's say I give you A and B, 3i for j, and B 4i to j. So what is the scalar product? Well, the more direct way to do it is ax bx plus ay by.
Okay, so it just depends on the problem.
What I mean is like this. Let me here. Let me open here. So if I give you one vector, A, 3i and 4j, and B, 2i plus 1j, and I want to make the dot product of A as A dot B. Well, I can do it in two ways. A dot B, for one side, is the magnitude of A by the magnitude of B by the cosine
Securing a pro plant
that form A with B. Yes?
Grey Goose delivered free. What's up?
What's up?
Mute your mics.
What? Okay, let me mute the mics, the mic of everybody. Let me see how I can do it. Participant, I think. Okay, the mute is already mute for everybody, but I need the camera of everybody. For example, Catherine Villa, please put your camera on. Albert Triana, same thing. Alfredo Gonzalez, Alex Atidor, and all of you that don't have camera, I want to see your face, okay? So.
I think I'm sharing it, no?
Yes, you are sharing now. Yes,
Oh.
yes. Adaji Escudero, yes. Alex Atidor is not sharing anything. Please share the screen. I want to see everybody here. I want to see the picture of everybody.
Question.
Okay, so.
Bro. Question.
The question that was like this. If I have two vectors, you see the screen? I'm writing.
Yes.
If I have two vectors and I have to make the dot product of two vectors, which of these two equations I will use to make the dot product of these two vectors? This equation or this equation? If I decide to use this equation, I have to calculate the magnitude.
It's not moving, Professor. It's frozen.
Let me. Okay. Now it's moving. No, it's not moving. It's still not moving.
Yeah,
The mouse is
I
moving.
see the mouse moving.
Oh, sorry. Let me see this thing again. Just a moment. Now it's moving. Has changed? Yes?
Yes.
Yes.
So if I have two vectors, A and B, they have the dot product of the two vectors. Which equation I will choose? This one or this one? If I decide to use this one, I need to find the magnitude of A. The magnitude square root of 3 squared plus 4 squared. Let me silence again. I don't know why. Let me silence you, everybody. Let me silence everybody. I don't know. Okay. So if I have to find A dot B using this equation, I will have to find the magnitude of A. I know how to find the magnitude of A. 3 squared plus 4 squared square root. I have to find the magnitude of B, this one. Yes, I can find a square root of 2 squared plus 1 squared. And to find the dot product, I need to find the cosine of the angle. So I'll better not use this side of the equation. I'll better use this side of the equation. So let's go to do it. A scalar B will be AX. How much? AX. AX.
3.
3 by BX.
2.
Plus AY
4.
by BY.
1.
Total 6 plus 4, 10. This is the dot product of two vectors. Now, if they ask me, what is the angle that they make? Oh, now I use this side of the equation. Now I make this trick. What is the magnitude of A? The magnitude of A is the square root of 25, which is 5. And the magnitude of B is a square root of 5. So now I use the other side if they ask me what is the angle between them. So it will be magnitude of A, 5. Magnitude of B, square root of 5. Cosine of alpha, and I know how to calculate cosine of alpha now. How? Cosine of alpha will be equal 10 divided by 5 square root of 5. Equal 5 by 2 divided by 5 square root of 5. Equal square root of 2 by square root of 2 divided by square root of 2 equal square root of 2. Cannot be. There is something, yes. Here. Sorry, what happened here? Let's go to review.
Wait, wouldn't it be 2 square root of 2?
Let me see. I know that I made a mistake. Why I made a mistake? Can you tell me?
When you're rationalizing a thing on the bottom, you put 2 square roots on the top.
Why I knew that I made a mistake? Why, looking at this, I know that I made a mistake. Why? Because cosine of alpha cannot be bigger than 1. And a square root is like 1.4, a square root of 2. So I made a mistake. So let's go to review. The dot product is 3 by 2, 3 by 2, 4 by 1, 4 by 1. 3 by 2 is 6, 6 is correct. This time is correct. The magnitude of A is the square root of 3 squared plus 4 squared. 9 plus 16, 25, square root of 25 is 5, is correct. The square root, magnitude of A by the magnitude of B. The magnitude of B is 2 squared, which is 4, plus 1 is 4, is the square root of 5, is cosine. So cosine, I rationalize it. So cosine of alpha will be 10 divided by 5, square root of 5, right? I put here, instead of 2, I put a 5. Okay. So 10.
I have a question.
10 is 5 by 2 divided by.
I have a question.
Yes.
Why did you do cosine of alpha equals 10 over that?
Good question. I start again.
Oh, jeez.
A scalar B is magnitude of A by magnitude of B by the cosine of alpha. Is this the definition of the scalar product of two vectors?
Yeah.
Is this a number?
Yeah.
Also, I have proved you in class that also A scalar B is AX, BX, plus AY, BY. Okay? So why I'm doing is because A scalar B is equal to A scalar B, something obvious. For one side, I will put magnitude of A by magnitude of B by cosine of alpha. Equal A scalar B, but A scalar B is also AX, BX, plus AY, BY. So the question that I'm using is that cosine of alpha is AX, BX, plus AY, BY, divided by the magnitude of A by the magnitude of B. So I'm
Understood. Understood.
Thank you. So I applied this equation to a practical case where the vector A is, I don't remember, and the vector B, I don't remember, but I can see, if you want, I use the same example, 3i for j, 2i, 1j. 3i for j, and the other one is 2i, 1j. 2i plus 1j. And I know that the magnitude of A will be 5. And I know that the magnitude of B will be a square root of 5, correct? So, and I know what is AX. AX is 3. I know what is BX. BX is 2. I know what is AY is 4. I know what is BY is 1. So I have everything to plug in into the equation to find cosine of alpha. So I plug in the equation. If I plug in the equation, cosine of alpha will be ax 3 by 2 plus 4 by 1 divided by 5 square root of 5. And this number has to be less than 1. That's why I knew that I was doing some mistake in a number. So 3, because the cosine of an angle is always less than 1, okay? The cosine of the angle is between 1 and minus 1, but cannot be 2, the cosine of the angle. So this is 6 plus 4 by 1, no? 4 plus 4, 10 divided by 5, square root of 5. So maybe I made the mistake rationalizing this. 10 divided by 5, square root of 5. 10 by 5 is 2 over square root of 5. And now you find what is 2 divided by square root of 5, and you find alpha equal. So alpha is the angle that if you represent A, 3i, plus 4j, 1, 2, 3, 4j, 4j, this is the vector A. And B, the vector B is 2i, twice, 1j, 1j. This is the vector B. If you represent A and B, there is an angle here. This angle is this one. Okay? Clear?
So that is it, huh?
And that is it. It's so easy.
Very good.
It's so easy, but I think that I did something similar on the video.
Don't you have to use inverse?
I have a question.
No, you did. You did.
Inverse cosine to
No.
find that angle?
I didn't do it.
Well, you
Yes, you did.
I did. Okay. So,
So,
more
Professor,
questions.
what is the difference between the one with cosine alpha and the one where ax by plus ay by?
You mean?
Like, what is the difference between those two? Like she was asking earlier, which one would you use given an equation or like a problem? How do you know which one to use?
Well, well,
Like, are they the same? They're not the same thing exactly, right?
let's go to think. If I give you a problem, when I say what is the magnitude of A, when I say what is the magnitude of B, and I give you the angle between between the two vectors, which one will you use? This one or this one?
I would use ax bx plus ay by.
Now, if I give you the magnitude of A and the magnitude of B, and the angle that they form, you don't have ax, bx, ay, by.
Okay, I see
You
what
don't
you're
have this information, so you better use this one. Now, suppose another kind of problem. I give you the components of the vector.
Okay.
I give you the vector. I give you the vector. I give you the 3 and the 4, the 2 and the 1. Which one will you use? Obviously.
second one.
Thank you, Professor. Can you hold the screen there? Let me take a picture.
Yes, I don't move.
Thank you so much. This makes sense.
Yeah.
So the professor has been recording his lectures. He just started uploading them onto Canvas, so you can find all of the lectures recorded on Canvas.
Thank you.
Okay. Every time that we finish the class, Zoom is making a record of the class. So be careful what you say of the class because it's being recorded.
Yes, sir. Buen provecho.
Gracias. So what I do is with this recording, I put it in my machine. And what I'm doing is I send it to YouTube and I create a link in Canvas in a way that you can see again the class if you would like to do it. Okay?
If there are any issues seeing them, I put my email in the chat, so just email me if you have any issues viewing the recordings.
I think there is, at the beginning, there were some issues because I don't want anyone to see this video, only you, because it's a private video.
Yeah, they all should work now, but just in case, if anything, just don't hesitate to email.
It's hidden completely, and it's a private video, so no one, oh, they are seeing your faces now. No one is recording your faces. If you don't like, you tell me if you have any. I think it doesn't mind. We don't have to be so, but we keep it private. And more questions. More questions. One problem from the homework that you didn't know how to solve. I give you this as a gift. I solve it and I give you, and you can submit it.
Can you explain how to find the angle between two vectors?
How to find the angles using the scalar product. This is the problem that we already did. This is exactly what we did.
Oh yes, never mind. I was looking from the wrong thing.
Okay.
Can you do a problem? Can you do a problem using the cross product with the thumb?
Yes, of course. Let's go to do one problem with the cross product.
After the cross product, can you do one on unitary vectors?
Yes.
Thank you.
Do you want to start with the unitary vector that is shorter and is nicer? Let's go to start with.
Okay, yeah.
It's shorter. Unitary vector. Unitary vector.
We still can't see the new screen, Professor.
Oh, sorry. Let me put it again. I don't know what the system disconnect my screen all the time. Now you can see, I think. You can see it now, right?
Yes.
Yes.
Okay. Let me start here. Maybe here better. Okay. So what did you ask me? The unitary vector. Okay, you see my screen? Do you see what I write? Yes.
With the yellow, yes.
Okay. So the unitary vector. The unitary vector of a vector. So what it means is, if you read the video that I made, the idea is like this. You have this vector. Let's say the vector A, 3i plus 4j. 1, 2, 3i, correct? Yes or no? 1, 2, I'm sorry, 3, and imagine 4, okay? 4j, imagine. This is the vector A. Okay, I wonder like this. You see the vector I? What is the magnitude of the vector I?
1.
1 meter. If A is position, 3i, it's meaning move to the right to the 3 meters. 1, 2, and 3. I, the magnitude of I, is 1. So the question is like this. If I make a circle around I, so I rotate from this point, I might create a circle from this. It will be this magnitude 1. It will be magnitude 1. Yes or no?
Yes.
Yes.
Yes or no?
Yes.
Of course, I'm rotating I and creating a circle. So the idea of the unitary vector So the magnitude of this is 1 here. This distance is 1. And this distance is 1. I have the distance 1. And the idea of this is there is one particular vector that I want to find. And is this one. The one that is on the direction of A. And this is the unitary vector that I want to find. So let's go to find it, okay? So I'm going to find this vector. So let's go to call this vector. I cannot call the vector I this vector because the vector I is this one. So I will call this vector the vector that is in the direction of I, of A. And have magnitude 1, I will call you U from unitary in the direction of A. You like this symbol? You?
No.
No, you don't like. You don't like.
It's good, it's good.
Okay. So I'm looking for a vector U sub A that when you multiply, let's say, this is the vector, 3i plus 4j. What is the magnitude of A? Quickly. What is the magnitude?
5, 25 squared and 5, yeah.
So I'm looking for a vector U sub A that when you multiply 5 times, when you sum the vector 5 times, 1, 2, 3, 4, and 5, you get A. You catch the idea of U sub A?
No, can you repeat the end after getting the 5 magnitude?
Yes, yes. So this is the vector A. Let's go to put the same vector. 1, 2, and 3. 1, 2, 3, and 4. 4j, 3i. This line, what is the distance of this line? What is the magnitude of A? What is the magnitude of A? Tell me.
5.
Thank you. So I'm looking, this is the vector I, but I'm not looking for this vector. This vector is already in the X direction. I'm not looking for this vector. I'm looking and I imagine that if I rotate I around a circle and after rotated, I pay my attention to this one, to this vector, and I'm wondering, if I call this U sub A, can you tell me what is U sub A? What vector is this? Of course, it has components, this vector. It will have a small component, less than 1 in the I direction, and less than 1 in the J direction, this vector. This vector is a combination of something in the I direction, something that is less than 1, plus something that is also less than 1 in the J direction. Do you agree? Yes or no? See,
Yes, it's less than 1 in both I and J.
This is U sub A. This is A, the vector A. I'm looking for a vector that if you magnify U sub A 5 times, 1, 2, 3, 4, and 5, you get A. I'm looking for U sub A in a way that the magnitude of A by U sub A will cover the vector A. I'm looking for a vector A where the magnitude of A times 1, U sub A, will be the vector A. So U sub A is simple, the vector A divided by the magnitude of A. So I'm looking for this vector. Let's go to find, and let's go to check that this vector is here, the one that we are doing. So, oh, I can do it. Okay. So the vector A is 3i plus 4j. Am I looking for U sub A? And I said that the way to look for U sub A is take the vector A and divide by the magnitude. what is the vector A? Yeah, plus 4j. And what is the magnitude of A? 5. So the vector is 3/5 I plus 4/5 j. This is the vector u sub A. Now it comes the final proof. And the final proof is to picture, to draw this vector and to see that this vector first is unitary. What does it mean unitary? The magnitude is 1. And the second test that it has is on the direction of what? Of
the vector.
Of the A of the vector, correct. So let's go to prove that this is correct. So the vector that I found is u sub A equals 3/5 I plus 4/5 j. There is any doubt how I found u sub A?
No. So what you did for this was you got the vector, the components of the vector divided by the magnitude of the vector.
Exactly, not the component of the vector. I take the vector itself, the whole vector itself, and I divide by the magnitude, so I create a small vector that is on the direction of A, but with magnitude 1. So let's go to check that this has the magnitude 1. What is the magnitude of u sub A? The magnitude of u sub A is the square root of 3/5 squared plus 4/5 squared. And what is this? It's 925 plus 1625. And what is this? It's 25 divided by 25. Oh, it's 1. It has passed the first proof, the first challenge, to be able to find a vector that has magnitude 1. This vector has magnitude 1. The second test is I'm looking for a vector that must be on the direction of A. Is this vector on the direction of A? Well, let's go to picture. Let's go to picture. But to make the good picture, I'm sorry if I make a, okay, it's 3i. Okay, let's go 1, 2, almost, and 3, right? 1 and 3 and 4, no? 4. 1, 2, 3, and 4. What is the vector A? Is 3i, right? Plus 4j? Yes. 3i plus 4j. This is the vector A. Is correct or not? So I have to check that this vector u sub A is here. You see the 1. The vector will arrive until here? Good question. The vector will arrive until the point 1, 1?
Yes.
No. It will be a little bit shorter, but it will have magnitude 1. This is something that many students doesn't catch, but I will tell you. Give me 1 second. The vector u sub A is 3/5. So I divided 1 in 5 parts. 1, 2, 3, 4, and 5. And 3/5 means you take 3 parts. So the vector u sub A is 3. Let me use this. Is 3 times 3/5 and 4/5. 4/5. I divide the 1 in the j direction in 4 times. 1, 2, 3, 4. And I have to, no, I'm sorry. I divide the 1 in 5 parts. 1, 2, 3, 4, 5. And I go up. Well, it go up 5 parts and 3 parts. It is the vector u sub A. 3/5 plus 4/5. It is the vector u sub A. And if you draw carefully, you will see that it's on this direction, this direction, is the direction of A. Let's go to do another example to practice. Yes?
Yeah.
Okay.
Yeah.
Okay, I'll give you 2 minutes to do this.
Professor, I have a question.
Yes?
You said the unitary vector has to have two things. It has to have a magnitude of 1 and something else.
Yes, I said that at the end, the vector has to have a magnitude of 1 and has to be orientated in a space in a way that the direction of u sub A is the same direction as the vector A, because I'm looking for a unitary vector that is parallel to the vector A, but has magnitude 1. Okay?
Can you say that one more time, please?
Yes, of course, of course. This is the idea. This is the idea. One, 2, 3, 4, and 5. This is the vector 5i. Is correct? 5 times I. Okay? Yes or no?
Yes.
Yes.
Okay. This is the vector 5i. If I ask you for this, find me a vector that is on the line of the vector 5i and have magnitude 1, which vector will be? Find me a vector that is on the direction of 5i. If I leave it like this, you will say, well, okay, 10i also is in the direction of 5i, and 8i is also in the direction of 5i, but I'm asking 2 questions, two conditions. Find me a vector that is on the direction of 5i and have magnitude. The magnitude of the vector is the size of the vector, the length of the vector, magnitude 1. Which vector you will tell me that is this one?
1i.
1i, of course, is this vector. And what happened with this vector? That if you call this vector A and you divide by 5, A, you divide by 5, you get I. Of course, 5i. Divide by 5, you get I. This is the vector. So what we are doing is exactly the same thing that I have done now, but with a vector that is orientated in space in a different direction. So let's go to do it. So I repeat again, what we are doing is u sub A is the vector A divided by the magnitude of the vector. In our case, we have done u sub A equal the vector A, 10i, divided by 10. So it's I. So what I find that the unitary vector of 5i is 5i divided by 5. So what I find is I. So the unitary vector is I. So what I want to do is to do it a little bit more complicated. What is a little more complicated? Let's say that you have this vector, minus 3i plus 4j. The vector A equal minus 3i plus 4j. Is this the vector? Okay, is this the vector? Yes or no? Minus 1, minus 2, minus 3. This is the vector A. And I want to find u sub A. But you see, can you tell me what distance is from here to here?
No.
Yes, you can tell me Pythagoras theorem. This is 1. This is 1. Can you tell me what this distance is?
Square root of 2.
A square root of 2. And a square root of 2 is bigger than 1?
Yes.
Yes. Britannia, to whom are you talking? Britannia? Wow. Singing? Okay, so this is not the vector. It's a little bit shorter, correct? Because the magnitude should be 1. So let's go to 5. U sub A, this vector, the one that is on the direction of A. How I'll find the vector A divided by his magnitude. What is the vector A? Minus 3I plus 4j. Is correct. And what is the magnitude of the vector A? Again, 3 squared plus 4 squared, 25. The square root is 5. So the vector U sub A, unitary vector, that I'm looking is the vector 3/5 I plus 4/5 j. And if you go and you picture this vector, it will be this one. It will be this one. In the direction of A, this is the direction of A, pointing out in the direction of A is pointing out in this direction, but the magnitude is 1. So this vector is the vector that if you multiply by its magnitude, if you multiply the magnitude of A by U sub A, you obtain the vector A. Do it. Multiply D by the magnitude. And tell me if you can get A. Of course, look at this. If I multiply by the magnitude is 5, I will get 5 divided by 5, 1 minus 3i, 5 divided by 5, 1 plus 4j. So this is the vector, this is the equation. This is the equation. This equation and this equation, the first and the second are the same. U sub A is the vector A divided by the magnitude of A, while A itself, if you work this equation, A itself is magnitude of A by U sub A. So if you multiply the magnitude of A 5 times U sub A, what you will obtain is the vector A. This is not difficult, huh? This is not difficult, but it needs to be thick.
Professor, can you move the screen down just a little bit, please?
Down, you mean like this?
Yes, perfect.
Okay. So it is clear the unitary vector of a vector?
Yes, you need the magnitude of 1.
Mm-hmm.
And then, can you say the other thing in words, please?
I will write the unitary vector of a vector A denoted by U sub A is the vector that what have magnitude U sub A 1. Second, have the same direction as the vector A. 3 is obtained like A equal magnitude of A 5 times U sub A, you will get to A. If you make 5 times U sub A, so it's obtained like this. U sub A is the vector itself divided by the magnitude. Okay? Okay?
Yes, thank you.
Thank you.
Now is clear this concept? Hmm?
Yes, it's more clear.
Okay, I'm happy. But if you see the video, you will find the same explanation, I think. If you think that I didn't explain the same thing, let me know, because maybe sometimes I forget to explain something and could happen. Okay.
This explanation was more clear. Thank you.
Oh, thank you. Okay. So, would you like to make the cross product, or would you like to make one problem from the homework?
Can you do a problem of for cross product?
Yeah, of course. Let's go to practice cross product. Okay. What is the idea of the cross product? The idea of the cross product is to create new vectors. And why we have to create new vectors? Why we have to have headache? Well, because in physics, the cross product is helpful because there are physical quantities that behave like the cross product of two vectors. For example, if you have a magnetic field, P, and you have an electron moving in the magnetic field like this, or a proton moving with this velocity V, the force that is acting on the charge Q, on this charge, is something like this. Q is proportional to the charge, more force, but the crucial quantity is the cross product of the velocity and the magnetic field. The crucial quantity here is the cross product of two vectors. And the cross product of two vectors will create a new vector. And what vector will be in this case? The force acting on the particle. So let's say that the B is here, going up, going up, going up. The space is filled of this vector, and B is here. Can you tell me the force to where it will push? It will push up. No. It will push to the right? No. The vector force, where it will be? Well, the cross product say that B cross V is a vector that is not a number. V cross V is a vector. C is a vector that is perpendicular to the plane made by A and B, but in this case is made by V and V, the velocity and the magnetic field. So if B is going like this, and B is going like that, the plane is here. This is the plane, the screen. That's the plane, the screen. But the vector, the force, this force, is perpendicular to the plane that is formed is perpendicular to the plane contained within B and B. And the plane contained in B and B is this one, but the perpendicular is coming to my eyes or going through the screen. So the vector is perpendicular to the plane. So now I need to know It's not the same thing that coming to my eyes, the force, that going down to the screen, because the particle will move differently. And I need to know to where the particle will go. So how to decide? So we already decide that the vector, the cross product is perpendicular to the plane that form the two vectors. So imagine that I have two vectors, for example. You see my
Yes.
notebook? Suppose you have the vector V, let's say, or A, and the vector B, the magnetic field like this, they form an angle. Okay.
Esther, we can't see. It's still the
Now,
other.
now you can see.
It's on his speaker screen.
What? You can see my notebook?
Yes.
Oh, okay. Sorry.
Can you draw it a little darker? I don't know if it's
No need
quality of video.
no need to write anything. You see my notebook? Can I drive?
Since you're sharing your screen, we can only like see like the physical aspect of you only like in a small box.
I understand. I understand what you mean. I understand.
Oh, you can tap on his video, the with the little tiny thing, and it'll blow up big.
If you double tap.
Oh, gotcha. Thank you.
So this is my notebook. Okay, it's not disconnected, right? You are seeing what I wrote? Yeah.
Yeah.
So this is my notebook. Okay. See this axis. You see this axis of the notebook? Can I rotate the notebook like this, doing like this? Can I rotate? Okay? Yes or no? So imagine that I put two vectors on this plane, A and B. This is the two vector on the plane, on the sheet. Where is the vector that is A cross B? And I say the vector that A cross B is perpendicular to the plane of the notebook. So if I put it in this position, the perpendicular line is coming to my eyes. It's just exactly perpendicular. You know what is a perpendicular line, correct? If you have this plane, the perpendicular line is this one. Okay? But if you change the orientation of the plane, the perpendicular line is this one. If you change it, let's say, whatever, like this, well, the perpendicular line maybe is like this, okay? So the cross product C, the vector C that represents A cross B, is perpendicular to the plane. This is the first things that you must take in account when you calculate the cross product. So the first things that I'm going to ask you is like this. This is the vector I that is on the x-axis. This is the vector j that is on the y-axis. And this is the vector k that is on the zeta-axis, okay? You see the perspective, the three-dimensional perspective that is trying to make this kind of draw, okay? Do you see? Okay. Do you see the plane x theta? Do you see?
Yes.
Okay. Do you see that in the plane x theta there are two vectors?
Yes.
Which one?
I and K.
Okay. Do you see that perpendicular to this plane there is another vector in the picture?
J.
Yeah, the vector j is perpendicular to this surface. Let's go to make another picture. I, J, and K. Do you see this plane? Which two vectors are on the plane XY? Can you tell me?
I and J.
I and J. Which vector is perpendicular to the plane?
K.
K. So I say that I cross J is K, is the vector that is perpendicular. I say that the cross product of two vectors is a new vector that is perpendicular to the plane that is formed by the two vectors. Okay? Again.
Oh, that makes sense.
Thank you. Thank you.
Okay, so can you explain in your videos you said something about the thumb to see the direction of the new vector that was made?
Yes.
I put a video in the group chat, but I would prefer if you could explain just in case I was wrong.
Let me finish to
Oh, I
explain.
didn't see the video.
Let me finish to explain the cross product and we'll go to particular question. Okay? So this is X, this is Y, and this is C. Do you see the plane theta Y?
Yes.
What are the two vectors that are contained in this plane?
Is it K?
Yes, K and?
If you're including both squares, is it J?
The two vectors that are on this plane are J and K. They lie down. They are sleeping in the floor, in the plane YZ or ZY. So the two vectors are J and K. If I do the cross product of J and K, you know what I will obtain?
Is it I?
Is correct. You will obtain I. You will obtain a vector that is perpendicular to the plane formed by J and K. Okay? So the equation that you have is like this. It's interesting, this thing. A, J, K, C. I cross J, give K. Now I go to the second with the third. J cross K is the first, I. Now I go the first with the second, with the first, the last one with the first one. K cross I is J. Okay? So there is a rule involved here.
Professor, I have a question. So if you were to switch it around to J times I, would that make it a negative K?
Yes.
Okay, thank you.
J cross I will make negative K. So how to distinguish when it will be positive K and negative K? And there is a rule that you use your thumb. Your thumb. You can see me or you cannot see me?
Yes, we can see you.
Okay, I can see you. So this is A. You see A, my pen?
Mm-hmm.
Okay. It's called the right hand rule to obtain to where it will go A cross B. So this is A. Let's say that this is B. Let's say that there is a plane here between A and B. And I want to know to where it will go A cross B. I take with my right hand A and I close it going to B, and my thumbs will indicate to where it will go the cross product C. It will not tell me the magnitude, but it will tell me the direction. It will tell me that it's not like this. You take A and you rotate through B, it will give you going up. So this is called the rule of the right-hand side, I think is called this rule. Okay, so you can apply on this picture, you can apply the rule. Let's say I, J, so rotate A through J. Imagine your hand.
I think it's stuck again.
Is not connected? No? No, it's not connected, sorry. Let me connect it again. Now it's connected, no? So imagine that you have A and J. How to apply the rule of the right-hand side. You take I, you rotate to J, and your sum will be K. So I cross J is K. Let's go to do J cross K. So you rotate J through K in this plane, and if you take your right-hand side and you rotate J through K, your thumb will point it out in the, tell me, in the I direction. You see it in
Can you do it with your hands again, just so we can see it again?
Sorry, what?
Can you do it with your hands like you did before? Because I understand it on paper, but not with the hands.
Well, the hand is like this. The hand is like this. You see, the arrow is my hand, okay?
Yes.
Okay, let me put another color, this one. The arrow is my hand. I take the first vector, A, or I, this vector, and I rotate it. Can you imagine? With my hand to do this movement. Shh. I rotate I through J. If I rotate I through J, I will get my thumb on this direction. Okay. The other way that I like to do it is, for me it's easier, no? But many books, they use the handwrite side. I like to think in a screwdriver. You know, when you make the screwdriver, okay? If you make the screwdriver going clockwise, it will go in this direction. If you make the screwdriver going counterclockwise, it will go in this direction. Is correct or not? Have you used a screwdriver or not? So imagine that you have I. Imagine that you have I. I like more this way of thinking, but you have I and you have J, okay? And you have your screwdriver here, and you rotate I through J. So the screwdriver will make you to go up, okay? Okay?
Can you show us an example where it's negative?
Yes, of course.
Thank you.
Of course. So this is I, this is J, and this is K. If I rotate A through J, will be K. But if I rotate J through I, meaning that I will take this vector J and I will rotate like this, it will be like going like this way, it will go down, minus K. Minus K will be, okay?
Yes, can you do it with your hand too? With the negative part?
No, I cannot do it because the negative part, you have to imagine how your hand will move and move it in the inverse direction, and you say should be down. What I mean is that from I to J, to move from I to J, I can do it. with my hand. With my right hand, I can do it. And my thumb will point it out like this. So you have to think immediately that this is anti-commutative. If you rotate J through Gi, the result will be going down. But you cannot do it with your right hand side. You tend to do it with your left hand side and you obtain up, but it's not up, it's down.
I have a question.
Yes.
Would it be correct to say that when you need to rotate counterclockwise, it's positive, and clockwise, it's negative?
It's correct. If you imagine the plane, counterclockwise means going up to the plane.
Okay, that's much easier for me.
It's much more easier if you want. So this is, let's go to draw here. This
Counterclockwise is negative or positive?
Counterclockwise is positive.
Thank you.
Let's go to do it. This is A. This is the plane, and this is V. This is the plane where A and V lives. If I rotate A and V, and I'm here, this is my eyes, looking, watching from up of the plane. This is my eye. If I rotate A cross B, this is a rotation that will go counterclockwise. A cross B is, now the rotation is going counterclockwise. If you see from up. Is correct or not? Yes. If the watch will go in the opposite direction as normal if you see from here, from this. So if you go counterclockwise, it will go up. Okay?
Yes.
The A cross B is going up. And if you do B cross B, B cross A, will go down, because B cross A is an inverse rotation and will generate a vector that is also perpendicular to this plane, but going down. Okay? So you will have some opportunity to practice this later. Do not worry about the cross product. It's not so important now at this moment. What is important now is to be sure the concept of vectors, how to manipulate vectors, how to obtain the magnitude, the angle, the form, how to sum vectors, how to create the unitary vector of a vector. These are the important, and the scalar product is important, but the cross product will be important in 1 month. So now you don't worry too much about the cross product, okay? So, shall we do any problem from the homework? I want to help you. I want you to submit problems that are correct. Can we do a problem that you have not known how to solve it, that you are not sure if you solve it correctly? Can we discuss one of the problems from the homework? Have everybody, there are 81 people here. Oh, welcome to 81 people. Nice to see so many people. Elena.
How would you describe direction in a 3-dimensional space? Like, I know in 2 dimensions we can use like angles to describe it. So what would be the equivalent if there is one in a 3-dimensional space?
I don't understand your question. You mean that I have a 3-dimensional space and I need to define directions? Well, the direction is the direction of the vector. So the first thing that you have to understand is that to define a direction, you need a frame of reference. If you don't have a frame of reference, you cannot define directions. For example, let's go to see. How you will define this direction?
So there's no change.
Here at the end is a star.
There's no change on the screen.
This is the direction that will
We
point.
can't see the new screen, Professor.
Oh, again? Sorry again. I don't know why. I should find why disconnected. Okay, now, yes. So imagine that you have this vector that is pointing out to a star that is here. This is a star. How you define direction? You will say, is the direction that if you live in Earth and you pointing out in this direction, you will see the star. But the Earth is moving. How you will define this direction 1 second after the Earth is moving? So the solution is we plant a system of reference with the I and with the J vector. And we define the directions as the angle that makes with the x-axis. In this way, we can define direction. What happened in 3 dimension? 3 dimension is the same thing. 3 dimension is the same thing. If you have 3 vectors, I, J, and K, you will move in a space wherever you like. And this is the start. And I want to point it out and to say where the star is in reference to my frame of reference. So I will say, well, the star is here. So I will say, what angles makes the star with the k-axis? And I call it alpha. What angle will make what angle will make with the y-axis? And I call it beta. What angle will make with the x-axis? And I call it gamma. And these 3 parameters, these 3 angles, alpha, beta, and gamma, will define the direction in a space.
Would the angle between I and J be 90 degrees?
In this case, it's 90 degrees, the angle between I and J.
And what question would we have that we would have to like apply this, the angles of each section?
In 3 dimension, in this course, you will not have many problems. I think you will not have any problem in 3 dimension.
And just in case we do, how would we like calculate this with the trig functions or something?
Oh, to calculate the angles that makes one vector in a space with x, y, and z? This
yes.
Is very easy. Very easy. Let me explain. Imagine that you have the vector A, 3i plus 4j plus 1k. This is my vector A. 1, 2, 3, 3i, 4j, 1, j is here, 1, 2, 3, 4. But let me put here 5k to go up. 1, 2, 3, 4, 5k. So my vector is this one. And I want to find this angle. The angle that makes with the zeta axis. Can you tell me what you will do? Please tell me 1 point. 1 point. Tell me how you will find this angle. Alpha, the angle that makes the vector A with the zeta axis. 1 point.
Dot product.
Dot product. A scalar k will be magnitude of A by magnitude of k, which is 1, by the cosine of alpha. So, what is A scalar k? It's 3i plus 4j plus 5k. A scalar k, 1k, equal 1 by 3, 3. I scalar k, tell me, 4 by 1, j scalar k plus 5 k scalar k. How much is I scalar? How much is I scalar k?
0.
0, because they are perpendicular. The cosine is the magnitude of the first one by the magnitude of the second one by the cosine of the angle that they form. Cosine of 90, 0. This is 0. This is 0. What is k scalar k? What is k dot k?
1.
1. So the scalar product of a scalar k will be 5. Correct? Yes or no?
Yes.
And equal to what? We already saw. Equal to what?
To magnitude of A times magnitude of K times cosine of alpha?
No. I have two vectors. The first vector is this one. The second vector is the vector k that is 0i plus 0j plus 1k. This is the vector k. So what is bx? 0. What is by? 0. What is bc? 1. What is ax? 3. What is ay? 4. What is az? 5. What is the cosine of the angle? Cosine of alpha is ax, bx, plus ay, by, plus ac, vc, divided by a scalar b. But I know how much is a scalar k. So cosine of alpha will be ax, 3, by bx, 0, plus ay, 4, by by, well, by is this one, k 0, 0, plus az, 5, by bc, 1, divide by a scalar k. A scalar k is 5. Is 5? Yes? Sorry, the vector k is 1. Let me see. Sorry. A 3i plus 4j, I make a scalar k, and a scalar k is 5, and now I'm making the magnitude of a, this is wrong, by the magnitude of k by the cosine of alpha, and this have to be 5. And cosine of alpha have to be equal 5 by magnitude of a square root 3 squared plus 4 squared plus 5 squared by the magnitude of 1. This is the cosine of alpha. Found it. Okay? Do I do it?
Professor, can you move down a little so I can take a picture of what's down?
Sorry?
Can you move the screen like a little bit lower so I can take a picture of what?
Yes. Yeah. Like this, no? But this is, this is not a scalar b, it's magnitude of a by the magnitude of b. So cosine of alpha will be ax. Remember that a is, can you tell me, is 3i plus 4j by plus 5k. This is the a that I put. Yes, no? Yes? And the k that I put, the b, the vector b is 0i plus 0y j plus 1k. So I want to find cosine of alpha based on this expression. Is a scalar b, or this expression in the numerator divided by the magnitude of a by the magnitude of b. So cosine of alpha will be 3ax, 3, by bx, 0, plus ay, 4, by by, A y is 0 plus AY 5 by BY, the components y of the second vector is 1 divided by the magnitude of A. The magnitude of A is the square root of 3 squared plus 4 squared plus 5 squared. This is the magnitude of a vector in 3 dimensions by the magnitude of B. The second vector is K, and the magnitude of B is 1. So with this, you obtain alpha. How? Well, this will be 5 divided by 9, 25. 25 is the square root of 50. So will be this. So alpha will be r cosine of 5 over a square root. And this is the angle that the
Professor,
vector form with the k-axis. Okay?
I have one question, sir. How did you get 1 is the magnitude of K?
How do I get 1? This one?
The magnitude of K is 1.
The magnitude of K is 1. How do I get this? Why the question is, you are asking me why the magnitude of K is 1?
That's correct.
Okay. Why? So, the vector I is the vector that I put only a cap here, and I say that the magnitude of I is 1 because I put a cap here. It's meaning that I create on the x-axis a vector I that goes in the x direction and have the magnitude 1 meter. It's go until the magnitude of the vector is 1. When I talk about j, I put a cap j here, and I create a vector in another direction, j. And I say that the cap means that the magnitude of j is 1. When I create k, I put I and j here and k here. And what I say that this vector, they are unit vectors because I want to know in space how far you will go if you are here. If you are here, maybe you will go 10 times k. So if this distance is 1 meter, you are 10 times, 10 meters from the origin in the zeta direction, following k. So the magnitude of k is also 1 because I choose it in this way. So your question is why you choose the magnitude of I and the magnitude of j and the magnitude of k to be 1. Why you choose? Because I need to measure things. How do I measure things? Let's say that let's say that I'm a Martian, and I say you are 10 Martian distance. The car, imagine a Martian that comes. A Martian comes to the Earth, and he say the car is 10 Martians away, 10 Martian. He invented a unit. He called the Martian distance. And he talked to me and say, this car is 10 Martian distance from me. When he tell me this car is now 100 Martian distance from me, how I will know what it means? The only way to know is that the Martian and me, we agree what is 1 unit. And we say, listen, 1 Martian unit is like this. So once that we go to 1 Martian unit, if you tell me that it's 10 Martian units, I will do like this 10 times. and I will arrive to the car. If you tell me now that the car is 100 times Martian units, I will go, but what is a Martian unit? I don't mind, it's a Martian unit. But now it calls my cousin and say, let's go to do a comparison. What is a Martian unit compared to 1 meter? So you put it here and you see, oh, 1 meter is half of 1 Martian unit. So this is a unit or this is a unit? Well, for him, for the Martian, this is the unit. And for me, this is the unit. So we invent units to measure things. Okay? If your weight is 100 kilograms, it's because we invent 1 unit of 1 kilograms. And we say your mass is 100 times the mass of 1 kilogram. So you say, well, show me 1 kilogram, define 1 kilogram. So I say, well, 1 kilogram is the mass of 1 liter of water. So if your weight is 100 kilograms, means that if I put you 100 liters of water, the mass of these 100 liters of water and your mass will be the same. So I invent a unit. And the units that the humanity has invented are kilograms for the mass, are meters for the length, and seconds for the times. But now they came the British, and the British say, I don't like this unit. Let's go to talk about yards. And they invent his unit, and they say, this is 1 yard. Okay? He's the Martian guy who came to me and say 1 Martian distance. So unit is unit. You define 1 unit. You define 1 unit and you keep this unit in a safe place to see, to remember what is 1 unit of what you say. What is $1, for example? What is $1? Can you tell me what is $1?
100 pennies.
Huh?
100 pennies.
Well, a penny is a subdivision of $1. But what is $1 is a unit. It's a unit of money, $1. And how much it costs a credit in FIU? It will cost maybe 700 units of $1. So what is 1 credit in FIU? Well, 1 credit in FIU referred to the unit in dollar is $700, 700 units. But if you are in euros, is 700 euros? No, it depends on the unit. It depends on the chain that you make. It's not the same 100 yards than 100 meters because the unit is different. So you create units. So to avoid complication in physics about units, we only use and worry about 3 units. Kilograms, meters, second. And the other units that we invent are subdivision of the units. For example, the millimeters. The millimeter is a subdivision of the meters. We take the meters, we divide the meters in 1,000 parts, and we say one of these parts is 1 millimeter. It's another unit, 1 millimeter. It's another unit. You want to live with 1 millimeters and refer everything to 1 millimeters? Yes, it's quite acceptable. If you are very, very small, your size is very, very small, it's better that you use the unit 1 millimeter. If you are an ant, a small animal, it's better that you use, you say, I have walked 3 millimeters today. But if you are a man, it's better that you say, no, I have walked 3 meters. So if you walk 3 meters, you have walked 3,000 times what the ant has walked. Because 1 millimeters is 1,000 times 1 millimeters is 1 meter. Okay? So the units Units are something sometimes confusing, but once that you get used to thinking different units, it will be very easy, very easy. Okay? What else? What else? Sabrina Lasso.
In terms of like other problems you want us to ask you?
Yes, of course. I'm waiting for you.
Oh, okay. Honestly, I was confused by, do you remember there was in the components of a vector
Yes.
video?
Can we agree to change one word? I don't like the word confusing. I hate this word. So instead of telling me I am confusing, I want you to tell me, I want to clarify.
Okay.
Because this is what you really want to do. But if you say all the time, I'm confused, I'm confused, I'm confused, I'm confused. Yes, at the end you are right, you are confused. But if you say in your mind, I want to clarify, I want to clarify, I want to clarify, it's completely different attitude. So I want a positive attitude. So forget everybody, forget this word. I hate this word. Okay, what you want to clarify?
So I wanted to clarify, I wanted to see if you could do an example with an inclined plane problem.
But an inclined plane problems with what?
With an object creating a downward force with the vector F.
Yes, but this is dynamics and we have not seen just dynamic. Have you seen this course before?
No, but it was in the components of a vector.
Ah, okay. I know what you mean. I know now what you mean. This is the idea. This is the idea. And this is something that you have to pay a lot of attention because you will find all the time during the course this kind of problem with this angle. And you have to visualize the angle clearly. Let me explain you. You have an inclined plane like this. So maybe most of the problem has with an object falling down, okay? And the vector that is here is a vector that is the weight. And the weight will have a magnitude and a direction. So the weight is the force that pulled you down. Of course, on this body, this is not the only force that is acting on the body. There are another force that are acting on the body. But I want to focus only on this force. So you have this force and you have a system of reference. The X and the Y, the I and the J. So let's say that the magnitude of this force is 10. 10 is the magnitude of the force going down. So can you tell me what is the vector force?
In this problem, you mean?
Yes, in this context. Can you express the vector F in the base ij in this frame of reference?
I think your screen hasn't changed.
Oh, sorry. And again, let me disconnect. Now, have changed. Oh. Yes, sorry. Okay, now you see?
Yes.
Okay, this is the vector. The vector is pointing down in the minus j direction. If I ask you, what is the expression of this force? Can you tell me the vector expression for this force? Well, this force has a magnitude, 10, and has a direction. Which one?
J?
Minus j. So which one is the vector?
F.
The vector F will be a vector that has magnitude 10 and is on the J direction minus. Is
Okay.
that correct?
Yes.
Okay. So the question now is, once that we have this vector on the base A and J, this is the base A, I and J, I and J. Suppose that we need to create the components of a vector in a way that you will see this vector Tj, can be seen like this. This one plus this one. Also can be seen like this. This one plus this one. All of them will be 10j. You see, 10j minus could be, for example, this one plus this one. You see that I can find two vectors, infinite two vectors, that when I sum, I get minus 10j. Do you visualize this?
I'm having trouble. So you're saying that it can be, I'm sorry, could you do another example?
I repeat. You have this vector, 3i plus 4j. Can you show me two vectors that I will sum? This is two vectors, 3i, I will sum with 4j, and I will obtain a. Can you please let me know about two vectors that you sum and you get a? Is this the only possible combination to obtain a?
No, you can.
I can go 1i, and I go directly to here. So the vector I, A, is 1i plus this vector, plus this vector. And what is this vector? What is this vector?
B.
B. And what is this vector? If I want to put it, this vector is 2i plus 4j.
Oh, okay.
You catch it?
I see.
2i plus 4j. So this is the vector decomposition of the first vector and the composition of the second vector. And both of them will give A. The sum of this and this will be A. So my question is, if I have A, I have only one chance, one possibility to create A? No, I can do it like this. This vector plus this vector, C plus D, also will give me A. C plus D will give me A. And this is far from 3i to 4j, but the result will be 3i for 4 plus 4j. But
Okay.
You catch it?
Yes, thank you.
So the composition of the vector is important. So this is the problem that you will face a lot in physics, in this physics. This is an inclined plane. This is the vector f. And I want the vector f is minus 10j in this base, in the base aj. Okay, this is the vector minus 10j, have a magnitude 10 times in the direction of minus j, minus 10j. But suppose that for some circumstances, you want to express this vector in two different vectors, that the sum will be minus 10j. So you take this perpendicular to the plane, you take the perpendicular to the plane, you see? Perpendicular to the plane, and you are going to create two vectors, one's going on this line, and the other one's going parallel to this line. which are the two vectors that when I sum, you will get minus 10j? Oh, this vector, 1 until here, and now parallel to the plane until here. These two vectors, if I have this vector, this is the plane, and I go perpendicular to the plane, and now I'll go parallel to the plane. These two vectors, the sum of A plus B, will be the force F. So it's true that the force is minus 10J, but it's also true that A plus B will be minus 10J. You catch it?
Yes.
Okay, so we need to know what is A. And to know what is A, I need to know what is this angle. So this angle, I call it alpha. And by something that I will explain at the end, is the same angle that's alpha, that is here. This angle and this angle is the same one. Okay? So what is A? A is a vector that goes in this direction. But this direction is not the I direction. It's not the J direction. So let's go to call it to J prime direction. And A have a magnitude. Can you tell me what is this magnitude? Well, if this is 10 and this is alpha, 10 cosine of alpha will be the magnitude of A. Correct?
Okay, but we don't know the value of alpha yet, though, right?
Well, let's say 30 degrees.
Okay.
It will be 30 degrees.
10 cosine of 30 is 8.6.
Whatever is in the J prime direction, because I chose the J prime direction to be like this. And
But
what
do we need to, I have a question. Do we need to put negative 10 or just 10?
Well, if you put J prime here, going up, it would be minus J prime. Okay? If you define J prime the direction positive, going in this direction, it's clear that A is going in the opposite direction, so you have to put the minus. So if you define I prime like this, well, this vector is pointing out in the minus I prime direction. So show us what is B.
Yeah, you should know him prior to all this.
Sorry?
Yeah.
Mute
your mic.
I have another question. So this is like another axis we're making, right? Like the prime. So it has a direction, like I prime has a direction.
Sorry,
J prime.
what?
That did you make? Okay, the J prime and the I prime. You have to assign a direction to it. It's not like a regular axis, that I don't know.
It's a new direction that I invent to solve the problem. It's but it's clear. It's clear. Let me finish. It's clear. I have this vector. I have this vector, and I have this picture. This is parallel to this. I have this angle, alpha. I have this angle, alpha. I have this magnitude, let's say 10. Can you tell me what is the value of this? It's 10 cosine of alpha. Can you tell me what is the value of this? 10 sine of alpha. So the vector 10j in the minus j direction, minus 10j, this vector, this one that's going down, can be done like two vectors, can be done like the sum of two vectors. This one with this magnitude, and this one with this magnitude, yes or no?
Professor, is this similar to the cross product?
This doesn't have to be anything with the cross product.
Okay, never mind.
Okay? So this is 10 cosine of alpha. This is 10 sine of alpha. Can you write me the vector? Now, can you write me this
Yes.
vector?
If
So if I call this vector A, the vector A, and I call this vector B, I know that minus 10j is equal to A plus B. But A is 10 cosine of alpha in the j prime direction. And if you want, I put it minus because j prime will go up. And B will be a magnitude that is 10 sine of alpha. If I call I prime like this, going parallel to the plane will be I prime and will be minus 10 I prime. So minus 10 j, this force, are decomposed into two new vectors. One is 10 cosine of alpha minus 10 cosine of alpha j prime plus minus 10 sine of alpha I prime. So what you really want to pick to catch is that this distance is 10 sine of alpha. At this distance is 10 cosine of alpha. This is what you really have to catch. Okay? And if you catch this, perfect. Okay?
What is this referring to? Like what chapter or like what
this
kind of
was in the chapter of components of a vector.
Component of a vector, it was on the component of a vectors, and you will need to visualize this picture when we do problems with Newton law.
Are you going to go over this again when we get to that point?
Yes, of course.
Okay.
Of course.
Thank you.
Thank you, Professor.
I have another question. So when we're doing problems like this with force, you have to use an angle that's on the y-axis, not on the x-axis.
When we are doing problems with force, yes, what?
Because I remember this question from one of your videos. You put like a box and then there's like the force going down, and that's, I assume that is negative 10j, right?
Yes.
Okay, so with these problems, you know how you made like you kind of made like a new axis, like a new coordinate system to solve this problem, right?
Yes.
You use the angle with, let me try to draw. Like you use this angle using the y-axis instead of using like this angle. Like, do you have to use that angle when you're doing force problems?
Do I have to use this angle? You mean?
Because usually we use like this angle, right?
Which?
I mean, I use the one that I just drew. Can you see what I drew?
Oh, let me see. Let me see. What you did?
The yellow.
Yellow. Yeah, I'm seeing. Yes.
So how come we didn't form the triangle? And
this angle you can use, but call this angle beta. Don't call it
okay.
alpha.
Oh yeah. Okay.
Call
So you
it
can use
beta
whichever angle.
because the alpha angle is this one. This one is the alpha angle. And this alpha is related to this. So if this is 90 degrees, this angle will be beta, and beta will be 90 minus alpha. This will be beta. If you want to use this angle, it's perfect, no problem.
Oh, okay, that was my question.
Okay. From the problems that I have asked you to do I think that I make a picture of the textbook. Did you make these problems?
We didn't have a problem like this. This was just in one of the videos, but it wasn't homework, I believe.
I mean, from the problems from the textbook, I copied some problems that I think that they were interesting, Let me see if I can find a problem here. Let me see. Let me see. Let me see. For example, this kind of problem, did you do it? Huh?
Yes. Yes.
And
We did it last class.
and no problem to do it?
No.
Eventually.
So happy.
Yeah, there was some problem.
Yes? Which one?
The one you just showed, you did it in class, but it was kind of difficult.
Yes.
You don't have to do it now. I'm just saying it was kind of hard.
Oh.
Based off of what we learned in the video.
Oh. Well, I think it's a question of practice. The first time that you encounter this kind of concepts and idea is your brain needs to digest.
Yes, Professor.
But you will do it if you concentrate on the basic idea. You will do any problems.
Professor, I have a question or something to ask.
Yes.
Next time when you make the videos, can you make the content of the videos related to the homework more?
Explain me better.
So
like have more examples that are similar to the homework.
Yes.
To add more examples.
That are similar to the homework that you're giving us.
But you mean to add it as a homework, or to add it that you want me to see how I solve it?
Yes. So basically, if you give us a problem from the textbook, for example, can you try to solve the same problem using different numbers?
Of course.
So we can see how, yes, because that was an issue a lot of us had last week, where we watched the videos, but then when we got to the homework, it didn't 100% match. So if you could try to make it match a little bit more, but change the numbers so we can get the idea, please.
I can do it.
Or
But the best
maybe we can get a.
Listen, the best way, if that happen again, the best way is that someone tell me in advance and I do a similar problem on the video, because maybe, there are so many ideas to put that it's easy to forget something.
Maybe.
You remind me, please do one problem like this and I will include it on the video. Okay?
Maybe I was thinking for the homework, maybe you can include, instead of like handwritten ones, maybe you can just grab one of the questions from the book and put it in there like you did with the other ones.
Yes.
I find those a lot easier to do them from the book than maybe some of the ones that you created. But that's just an opinion.
Yes, definitely I can do it. But let me explain. We go step by step. What is my idea? My idea is that the basic thing that you have to know about vectors and, well, in this subject is only vectors. The basic idea, you catch it. Now we'll go to the details. But if you don't catch the basic idea and we want to go very fast to the detail, you will not catch the detail and you will not catch the basic idea. So I would say that maybe we have to work in two phases. First phase is to understand what's going on here. Second phase, to be able to use what we understood to specific problems and to see clearly why we can apply what we understood to this specific problem in an easy way. But to do both things at the same time is what is complicated. At the end, my experience say that you don't
end understanding the basic principles, and you don't end solving the problems. So step by step, we have to go in 2 steps. Phase 1, we concentrate on understanding. Phase 2, we challenge ourselves with problems. This is the way that I plan to work with this course, okay? What else?
Yes.
What else?
I think
So
that's it.
attendance. Let me talk to you about attendance. We are how many people now? Let me see, people, 75. Some people is not here. They abandoned me. 75 people. So, you know, attendance is, someone told me that the system is not working with attendance, and it's true, it's not working. The reality is that I cannot be naming all of you to see if you are here or not here. So I will see a number, 75. I will imagine that 10 people, 15 people, they are not here. And I have asked a student to please take care who is not here. And at the end of the semester, I will see a percentage of the attendance that you have made, and I will grade you for the attendance, okay? But do not worry too much about points. Please do not worry about points. Worry about learning. Worry about things that are important in life. Points are not important. And you will realize this in 10 years. When you are working, when you are doing anything, and you will see, you will think, attendance. It was important, the points that I got for attendance. This is a system that makes you to eat points. I hate. It makes you, it give you a sandwich, cheese and ham. The cheese is the knowledge. The ham is the points. And the system asks you, please eat the sandwich. So because you are so many people, this is the only way the system makes you to work. With a mixtures of knowledge and points. So most of the people, and I'm going to use this word, confused. Most of the people, they are confused. They eat the ham, the points, and they throw away the knowledge. And this is ridiculous because it's opposite. It's opposite. So the system is making you to give you not a pure sandwich of knowledge. It's always cheating you in some way. It gives you points with knowledge. It say, if you get this knowledge, I will give you some points. But what will you do with points? Not useful at all in your life, the points. Not useful, it doesn't work. They will give you a paper that will say you are an engineering because you get so much points. But if the knowledge is not with you, what is the worth of these points? Nothing. So my advice is, do not concentrate on points. Concentrate on learning, on understanding, of asking your professor questions to make you understand, to push and make pressure to your professor, not to give you points. What for to give you points? Make the pressure to give you knowledge and don't waste your time. My advice.
Thank you.
Thank you, Professor.
So I'm uploading Unit 3. It takes me sometimes to to upload Unit 3. I have cut it, Unit 3, in so many pieces. You know, I told you the other day, I like to teach in the chaotic way. What is the chaotic way? The chaotic way is the way where you are seeing the whole picture and you are telling about all the pieces that you see on the picture and how they are connected. And at the end, when the guy explains you what is happening, you connect the pieces and you can see the whole picture as a unit. So I have taken Unit 3 and I have divided in too many pieces. It stayed for me the challenge to make a video, to unify all the pieces, to give you the complete picture of what's going on. I think I will do it. I think I'm near to do it, to finish. So I will upload all the videos and all the homework for Unit 3 between tonight and tomorrow, and work Unit 3. And on Tuesday, we will have a quiz, half-hour quiz, 4 questions, Unit 1 and Unit 2.
Will it be, and were you going to write it out, or are you just going to tip it into a Canvas and we take it on Canvas?
We will do it like we are doing now, the class. I will put it on Canvas, and you will do it with the camera on, answering the problems. I'm not sure if the problem will be 4 problems or 6 problems. I'm not sure if the problem that I will create will be multiple choice. And I don't know how I will do it. I'm going to be honest with 74 people that are here. I like people that are honest. Honest not in the way that they only are not going to cheat me on the exam. Honest in the way that they are going to come and they are going to say to me, help me to understand this. Help me to get a better grade that I will study more. Help me to do things like this. But to copy, I don't like, because destroy my effort. It will destroy my effort. So I want you to focus on learning, on understanding, not to worry for the points. Trust me, I will help you to get the points that you need. Trust me, I will be with you. Concentrate on this. Finish this course saying to yourself, I have learned something valuable. Now I can see the stock markets and I can see the values of every share, how change the value, and I can imagine things that I have never imagined how to make it in my mind. So try to make this course to learn something valuable for you, not for the points, not for me, for you. And work with your mind, work honestly, work for understanding. So on Tuesday, we will have quiz 4. One of my doubts is, I'm honest with you, they will copy. I know you can copy, I know. But if you copy, you are not cheating me, you are cheating yourself. So I will see how to do a reasonable test, not to punish you, to challenge you to learn, to challenge you to discuss why this is solved like this. So don't be worried about points. Be worried about who you will be in 10 years. You will be engineering that doesn't know anything about physics. You will be a person that doesn't understand the meaning of the things, or you will be someone with a criteria, with a mind, with a with his own thinking for himself. So think for yourself and don't stop thinking. Don't stop thinking. Stand up and fight. This is your lima. So go ahead. I'll see you on Tuesday. First part of the class will be half an hour for the quiz. After that, we will go to Unit 3 and we will run for Unit 3 during the week. And I hope we will finish Unit 3 and we'll go to Unit 4 and so on. So have a good weekend. I wish you all the best and I'll see you soon.
So for the quiz, if there is any formula involved, either formula will be given or do we have to memorize them?
I don't like you to memorize. I don't like at all to memorize, but let me explain you. Here, there are no formulas. At this level, indeed, they are not formula, they are concepts. If you don't know the concept of the component of a vector, what formula is this one? It's the concept, the component of a vector. So I would say that I don't mind if you need any formula because it makes you to feel more comfortable or more confident that you can do it. I don't mind. It doesn't say anything formula. What it says, the meaning of the equation. And in the meaning of the equation is, you know or you don't know. You understand or you don't understand. The problem that I do and that I ask, that I request to do it, they cannot be done using a formula. You have to think what's going on the problem. It's not a question that you put the data on a formula and you get the result. This is making you to waste your time. Because what you learn doing like this, to use your calculator, okay, fine, you are very smart using your calculator, but about what you have learned, nothing. So the problem that I will ask you, request that you think. So keep thinking, okay? So I'll see you on Tuesday. Good luck, anything, write me and go ahead.
Professor, is all of Unit 3 supposed to be complete by Tuesday?
Is the Unit 3 to be completed on Tuesday? No, I don't think so. I think we will need like Tuesday, Thursday, at least.
Okay.
Okay. Between Tuesday and Thursday, we will finish Unit 3.
All right, thank you.
Okay, anything else?
Professor, can we have maybe like an assistance sheet, whether it's for the concepts or like specific concepts that we should just keep in mind? Can we have like one sheet of paper like that?
Yes, I have one student coordinator and I have requests to make something like this. And I hope she will have ready in the next, maybe tomorrow she will have ready. And I will put it on Canvas so it will be even easier for you to study and to review the material. And I hope it will be more helpful like this.
Okay.
Okay. So I need some help. I need some help. So when I ask you for help, you know, sometimes I'm scared with a student. If I say I need some help, maybe the department of physics will call me and will ask me, are you asking for help to the student? What are you asking? I'm not asking for help. I'm asking, let me help you. Let me help you is the question. So I need help to be more helpful for you. I need help in the way that maybe I need someone to help me to post some notes or to post whatever I ask. Okay? So be more collaborative between yourself. I like collaboration in the way that if you make the homework together, you will learn more. I'm sure that discussing the concepts and thinking together is something very valuable. Of course, if the group has 3 people and 2 people doesn't think, doesn't work, the other guy will feel stupid in the group because he's the only one that is working. But if you do it in the honest way and you say, I can do it, I can do it, I'm not worried about the points, I'm worried about the knowledge, I'm worried to know how I can do this problem. I'm worried about how I can imagine the problem working. If you do it in the honest way, you will learn, you will enjoy, you will discover a new world. So I'll see you on Tuesday.
Thank you, Professor.
Okay. Bye.
Thank you.
Bye.
Bye.
Bye. Oh, yeah.
Professor,
Yes.
sorry, one last question. I'm taking math as well. I'm an architecture major, and the professor is also concerned about the students learning the material. So something he's doing is basically after quizzing us or testing us, he's giving students the option, if they got any questions wrong, to rework them, and he'll give them partial credit for it.
I don't mind.
You don't mind that? Okay.
Not at all. What I mind is that you take a quiz and you learn from the quiz.
Yeah.
Why you are going to waste your time for nothing? If you don't know how to do the question, why you are going to forget? No. If you don't know how to do the question correctly, learn how to do it. It's an opportunity. Why to waste the opportunity? Of
So
course.
okay. So for that, because right now we're trying to set up different study groups. So we're all trying to tackle the homework together and the concepts together. Like we're already doing that. We're just concerned about how the format of the quiz and the tests, and we want to make sure we know the right information, right? Of course, knowing everything is great, but we want to know what we should practice the most. So kind of everything we've covered to fit in.
I think that I have posted on Canvas problems to solve, like a quiz. Let me see if it's posted or I forgot to post it.
The practice quiz is posted. Is that what you're talking about?
Post it, yes.
Yeah, go under quizzes, and there is a practice quiz for Unit 1, and there's also a practice quiz for Unit 2. I'm going to be going through those today and doing the solutions for them and sending those.
Cool.
I think that if you practice problems for this material, for these quizzes, and you try to do it thinking how to do it exactly to be sure that you are doing the right thing, and if you are not sure, you ask.
Right.
I think it's going to be very helpful. Okay.
Thank you, Professor.
Okay. Well, bye. I'll see you.
Bye.
Okay.
Unless someone else has a question for the professor, can you leave the meeting?
Any questions? No, I think no. Dane, how are you?
I'm good. I was going to discuss the things that we were talking about, but I think the rest should leave the meeting. So I don't know if you want to end this meeting and start a new one.
Yes. Okay, we'll start a new one.
Okay, so end this meeting and I'll join back to your link.
Okay. Give me 1 minute.